Okay, so we should be back on unless this stupid headset decides to die again.
No, my headset's not stupid.
Okay.
Awesome.
So, I would like to clarify some stuff from our previous video. So, the reason why we have so many different types of variables, they're not really that many, but the reason why we have different types of variables is because of the way they're stored in memory. Each one of these variables has a different size to it. And I cannot remember them from the top of my head, actually, but they're. Let me remember. Come on, I can do this. Just a regular number, an int variable, is
Yes.
4 bytes.
Yes.
Then we got floats, which are 8 bytes. And then we got doubles, which are
Double
16 bytes.
Yes.
That's what they're called, doubles. And then we got character variables, which
I believe they're only 1 byte per character.
Yes. And booleans.
No idea. Probably 1 byte as well.
I would even say 1 bit. What would you need more? 0, 1, right?
I don't know. Yeah. I don't know.
Okay.
Probably 1 bit or byte.
We'll probably tell you
Doesn't
exactly.
make a difference, right?
This is more of architecture stuff, so ignore that. The reason why you need to declare these variables to be different is because the space that they take in memory is different, and you need to allocate, which means create as much space as you're gonna need. And you don't want to use more. You don't want to declare everything as doubles. You don't want to declare everything as floats. You want to use as you need. Basically, is what I'm saying. Oh, and naming conventions. Actually, it's something a little bit weird over here. I would actually suggest that you keep your naming consistent. So let's just change that real quick. Yeah, so you can actually name your variables whatever you want. There's not a single reason. There's nothing that you can put in here that, oh my gosh, Stegosaurus. Okay.
So it's okay. Got this under control. Oops.
Just exit Steam, sir.
I
So unprofessional. Look, I can't work like this. I cannot work like this.
Sorry,
Anyway.
my friend Stegosaurus had to say something.
Okay, so going back to what we were saying. Lost my train of thought. Good job.
We're talking about your variable names.
Oh yeah, variable names, correct. Variable names can be anything, but you should make them as descriptive as possible. Because you don't want to call, let's say, an integer variable broccoli, because it doesn't quite make sense. And you have to mind your context when you're naming your variables. The better you name your variables, the easier your program is to follow. The easier your program is to follow, the better your professor will understand your code.
Yeah.
Better your grade will be, probably, because you get them in a better mood.
Yeah, if it's easier to read your code, it makes it easier for your teacher or somebody else who's either looking at your code to grade it or to help you. If they can read it, it's much easier to find out where your problems are and things like that. So I take it Puga is going to display a number?
I am going to display actually almost everything.
Okay.
Let's begin, shall we? Ah!
I guess we go from the top down.
Yep.
Let's do the 2 booleans first.
Can you actually output booleans like that?
Yeah.
Oh,
Sure.
let's do it.
Let's find out.
This is always fun. See, when you actually progress in computer science, you sometimes forget about the little stuff that you take for granted.
Yeah. And then you just have to trial and error. And if it doesn't work, then you remember that it doesn't work.
What did Dr. Wang used to say? He used to say, you get things wrong multiple times and it takes forever to fix, but the one time you get it right, you remember it.
Remember forever.
Yeah. Num 2. Num 3. Basically, what we're doing is we'll explain as soon as. Actually,
Yeah.
you can start explaining
So,
while I'm doing this.
What Puga's doing here is we're just gonna show you how these declarations of variables, the booleans, integers, float, double, and character, they're all saved into those variables, whatever we declared them as, and we're just going to print them out for you to show you that what we did save them as, like for num1 we did save it as 99, or we stored 99 into num1. We're going to print out and we'll see that it'll be 99. So you can kind of see how data is saved into these variables, and that you don't actually print out the literal number, we print out the variable. So if we wanted to change something, we just change it once at the variable, and it's carry on through the rest of the thing. Just like how in math, if you were to set x equal to 3, you just plug in 3 for where all the x's are. It's the same principle.
I should have probably named the single characters a little bit better.
Nah.
Oh my gosh.
This way we know they're single characters.
Okay. Now, this will be fun if I actually misspelled one of the last ones, because you'll see what happens when you get a compiling error. I'll probably do that anyway. So, looks like I outputted everything.
Yeah.
So, as you can see, you can actually output the variables using the cout statements just like that with the with the carets.
And you'll have to on pretty much any homework that you'll end up doing.
Yep. And this is basically kind of like, I want to say, creating your own string. You're basically building a string with variables, but you're not actually saying this is a variable. You're saying this is the value that was stored inside of my variable, if that makes sense.
So yeah, when we run it, we'll see that it'll say here is, and then whatever was stored into test 1 is going to be printed out. So I think it was 99. So we'll check it out and make sure that it's that it works. Oh, sweet.
Oh, wow.
No errors. You did good.
I'm pro.
So it's our new A dot out.
I'm ready for my screen.
All right. Okay, so it was 1.
Oh, wow.
1 and 0, true and false.
Yep.
There you go.
Awesome. Okay, so we can go over this. Test 1 was set to true. As we said, any number but 0 is true. It outputs 1. Test 2 was set to false. 0 is false. When we output it, it's 0. Then the next one, we got number 1. Number 1 was 99.
Oh, you didn't change. What was 5? Oh, yeah.
Yeah,
that
I
was
did.
our examples for our floating points and stuff. Gotcha.
So the math people can see that rounding does not work.
Yeah, and it doesn't work at all.
99. That was our first integer. Second integer was 5. Go down here. It is 5.
Our third
Next integer, 5.1. It's really close to 5, so technically it should round out to be to 5. So it does 5, but not because of that. It just chops off.
Yeah, as an integer value, it just chops off any of the decimal places. So, as you'll see in the next line, we had 5.9.
Did I just output number 3 twice?
I think so.
Oh wow, look at me making mistakes.
It's okay.
It's okay. It doesn't. Okay, so number 4. So we need to go to number 5. 1, 2, 3, 4, 5. This is it.
Yep.
So it chops off the
9.
99999.
Yeah.
So it doesn't round off. So there we go. Proven.
Yep.
Proven fact by science.
So then we go to like our floating point numbers, and we see that we have decimal places yet again, but these are floating point numbers and doubles. And for these next 4, we see that we have our decimal places.
Correct. Just as so.
Did that do what I think it did?
Bye.
It did.
Oh, it chopped off?
It rounded.
Looks like it. Maybe because we didn't set precision. Yeah.
Yeah,
Well, that's something for later. Yeah.
Yeah.
And then let's go ahead and tell about the single characters. Yeah. So good thing I wrote them right. I'll write one wrong for you guys just in a second. So we output what's in character 1, character 2, character 3, character 4, and character 1 is A, character 2 is H, character 3 is H.
Capital H.
Capital H.
Welcome to America.
Oh, excuse me, sir. We usually say capital afterwards. Okay. And this right here, even though it looks like an L, it's actually a 1.
You don't even have H's in your alphabet.
They're in there, they're just silent. Okay. We output the very last one, and it's a 1. Just so you know, the 1 that we're using as a character is not the same thing as the 1 you use for math.
Yeah, you won't be able to do math with the character 1.
No, you use integers, doubles, and floats.
Yep.
Do not use a character to do math.
Yeah,
Please.
You will have problems.
Yes, and I will probably not catch it because I'll think there's no way that somebody did that. But it happens. Let me misspell something.
Yeah, let's make a compiler syntax error.
Oh my god, what am I doing?
Alright, so just got rid of the 4, and we're going to try to compile it again. And then we get an error. Okay, so it tells us that our error is in the function int main. And then we also get another line saying that on line 36, there's an error where it says single character. It wasn't declared. So when the compiler went down there, it found that variable name, and it could not match it with anything else. So we obviously misspelled it.
Okay, so I am going to go ahead and say this and get it out of the way. Your compiler is your best friend.
Yes.
Us tutors can do as much as we can for you to look up these types of errors. But honestly, the best way for you to do this is to actually work with the compiler, look at the line,
Yeah,
the first line.
Actually read the errors.
Yes, read the errors and memorize them. Understand what is going on with your error so that next time you see it, you know what it is instantly and you don't have to be hunting down from it. Because semicolons missing will cause you trouble. Getting the cout statement incorrect will cause you trouble. Forgetting the output carrots will cause you trouble. There's a whole bunch of stuff that's going to happen while you're in programming classes. And you're probably going to see it all. And there's stuff I don't see regularly happen. It blows my mind up to this day. We'll just see crazy errors. But the more that you mess up, the better it is for you, for your coding practices. The less errors you'll do, and the better it'll be. And, okay, so let's go ahead and show you how to fix this error real quick. So, since it says that single character is not declared in the scope, we go back in there.
It's on line 36. You notice on the bottom right, we have a 36,1. That's our line number and our character spot.
I just realized they can't see my hand, so they can't see me pointing.
Just keep pointing. You'll be able to tell.
Okay. I will add my 4.
Yep.
But this time, I am going to screw up something else. Oh, lordy. What am I doing?
You should... No, get rid of a semicolon.
Oh, okay. Whatever, Ken.
Because we already did that error. Let's try a semicolon error.
Okay. Fair enough. Let me just clear the screen. Oh, you can do this, by the way. It's really neat.
Yeah.
Clears the screen and compiles. Fantastic.
Alright, so you guys will probably see a lot of this.
Yes,
a lot of
you will.
Expected a semicolon before whatever.
Yes.
So yeah, same thing goes with this. We go to line 25 and then we check to see if we have semicolons where they need to be. So we'll just go down line 25 real quick, put our semicolon back, and we're good to go.
It's actually not line 25, it's the one beforehand.
Oh yes, that's another good point.
Yeah.
When if it doesn't happen on line 25, then it's always a line, not a line, but one of the lines above it.
The compiler will tell you where you screwed up in a general area rather than in the exact location sometimes. Oh,
it's gonna go to where it has the first problem. So when it didn't have a semicolon there, it didn't find an end of the statement, so it kept reading. And yeah.
I would also like to add one more thing to this. Most of your mistakes are always going to be with your variable names and semicolons at the beginning of programming.
Yes.
Please make sure that you are understanding what you're calling your variables and that semicolons are required in almost every single line of code so that you can separate them appropriately. Otherwise, the compiler doesn't know what you're doing. It's basically like making a sentence without punctuation. I'm not sure what you're getting done. Alright, this is enough for the second video. We will go over some other stuff on the third one.
Yep. Alright, that's it, guys.
See you guys later.